Okay, and we're live. Hi, everyone. Thank you for joining for the second book reading club session with Sam and his book, Building Microservices. Unfortunately, we're starting a little bit behind. We had a couple of technical glitches. What is the IT world without these glitches, right?
Yeah, right.
So with me, we have Sam, the author of the Building Microservices book. I actually got the book in the same day we got the first session in the afternoon. So we still got it pretty quickly. And we have here my colleague, Ivan. How are you guys?
Yeah,
Pretty
Roberto,
good, thank you.
I'm good.
Yeah, so we're going to do the same thing as we did on the first session. At this time, we're going to cover 4 chapters of the book. If I believe, let's try to do it on memory. Decomposing the monolith. Oh, okay.
Yes, splitting the monolith, deployment, testing, and monitoring.
Awesome. So I'm going to update a couple of links for you guys to see the video. Please join us on RC on Virtual Jug channel, and you can post your questions live to Sam. Before starting with this, we also have a question that I like to ask Sam. That was something that came in after the session on our forum, and this is quite a big text, so I'm going to try to summarize it as best that I can. So this is a user called DEGR. So basically, he's developing some applications, and basically what he's trying to convey is he has a couple of web applications based on out-of-the-box stuff, running on Windows, running on Linux, running on Flash, running on application containers, and basically what he's saying, he has absolutely no idea on how he can properly work with them, because most of those applications are out of the box and he doesn't have any access to its infrastructure. So all applications are on different servers. It's really difficult to work with the configuration files. All applications are different languages. So his question is, are these microservice applications? You think yes. It's easy to build with them. I think it's not. So why should he choose microservices instead of a monolith? In case when I have no out-box applications, I will guarantee it will work 10 times faster, and it will be managing 10 times more easy. It will be able to compile if there is something wrong. And if I have a pack of out-box decisions, how can I apply them to the project that will change non-compatible to compatible?
Okay, so there's a bunch of stuff there. The first thing is that that microservices are not universally a solution for all problems. There are certain problems where microservices could be a good fit, and there are certain places where microservices might be a terrible idea. It sounds like with his current application, he has a lot of off-the-shelf existing tools and applications that he can't change. But it sounds like they're all part of the same system. Therefore, he doesn't have a monolithic system. He has a distributed system. If you have 3 or 4 or 5 different off-the-shelf applications that are talking to each other, you might have 5 monoliths that are talking to each other, but you have a distributed system already. So I guess the question I've got is, what is it he's actually building? I mean, is he customizing those tools? Is he building a separate application stack? There's a lot of things to unpick there. When you do have sort of off-the-shelf tools, COTS products, vendor-based solutions, old legacy systems that you just don't have the code for anymore, if you a completely viable approach is actually to treat those things like black boxes. Like, I can't touch them, I can't change them. And so something I will do if I am looking to maybe build new functionality around the edges, I might build that new functionality in new microservices, and then I'll have what I often call a shim. So I might create a proxy that sits in front of the legacy system. So you might have, say, a legacy Windows system that communicates via some funky SOAP or WSDL schema. Well, you have your proxy that communicates with the horrible API, but it sort of hides that, and then you can talk to it via, I don't know, a nice protobuf or a nice REST API. So just rattling that off, if you've got lots of things deployed that talk to each other, you don't have a monolith. You might have lots of monoliths, but you have a distributed system. So you still have many of the same issues as distributed systems around things like transaction integrity, consistency, scaling issues, all those sorts of things. Microservices aren't a silver bullet. They're not applicable for everything. And if you have got something that has value that you need to keep running, but you can't change, sometimes hiding it behind a nicer layer is a good way forward. I talk about this a bit, I think, in the integration chapter. I have a section on legacy software where I go into a bit more examples of that. I think that's chapter 4.
Yep.
So I hope that was useful.
Hopefully. I'm not sure if this user is reading or is listening to us, but I'm guessing he can look into that later after we stream the video. Okay, so moving out to the chapters for today. Ivan, do you want to start with your first question?
Yeah, sure. So let's start with splitting the monolith. One common advice for a new project is to start it as a monolith, right? So you never usually don't start as a microservice architecture, you start as a monolith. And at some point you identify the need to split this monolith to microservices. How would you decide that it's time for a split?
Yeah, I mean, this is a really good question. So I actually defer back. In a way, there's not a quantitative basis for this all the time. It's not like it's a number. Oh, if the number's 4, we're okay. But when it gets to 5, we need microservices. There isn't a number I can give you. The short answer is when the thing you're dealing with feels too big for you to get the job done in the way you want to get it done. So we're not going fast enough because it's too hard to make a change. It's too big to manage. I can't fit it in my head anymore. It's when it starts feeling too large is a good reason. Now, when it starts feeling too large and you can't manage it, then the question is, okay, are there other ways to solve my problem other than microservices? Could I actually just define some modules? So I think when you're starting with a clean sheet of paper, I think monoliths make more, as in, say, a single process boundary makes more sense at the beginning. When it starts feeling too big, or when you start getting a firm enough sense of the domain that you get a really good sense of what those clear API boundaries might be, then you can make that split. The reality is you always go a little bit too far, right? You don't split something when everything's easy to work with, right? If you've got a code base and everyone's like, oh yeah, it's really easy to make changes and it's really quick for us to do deployments, then you don't make any changes, do you? You don't need to change the architecture. The point at which it ticks over into being, you know what, it's kind of annoying. Maybe we should make a split. And you've always gone a little bit too far. You're never going to catch it exactly right. The important thing is in your team, do you have feedback loops in your team? Do you have places where the team can actually clear their heads, stop and reflect about how things are going, and talk about it? I mean, maybe you said at the beginning of the project, we might move to microservices in the future. You've got that in the back of your mind. Maybe you have like a formal retrospective every month, every 2 months. You sit down together and say, well, things are going fine. I need to make a change. Or, you know what? It's going a bit slow. And this thing here seems really stable. Why don't we pull that out? So I think the key thing is it too large? Have checkpoints built in, have lots of conversations as a team, and have a good shared understanding of what pain is like for you across the team. You know, how long are things taking?
Okay, cool. Any questions from the audience, Roberto, or I should go on with mine?
Yeah, please go on. Still starting to have people asking stuff.
Okay, so while we are still in the splitting the monolith chapter, you talked there about splitting the database, and one of the common patterns in microservices is a database per service or schema per service. And it has some disadvantages, which you also mentioned in your book. And one of these disadvantages is the eventual consistency between these two schemas, because they can, the different services can have shared data or shared indexes or whatever. And you talk also about the data pump in other context in the same chapter. So would you recommend some kind of data pump for like event data pump, I mean, for dealing with this eventual consistency? So if I change anything in service A, then I push an event, and then the other microservice listens for this event and updates the shared data in its database.
It's actually slightly worse in a way than what you outline when you split a schema. It's not that you get eventual consistency, it's that you can't guarantee any form of consistency. So, you know, within a relational database, there are some consistency controls that make sure data is in sync. When I split my data model across two schemas, I'm having to implement any kind of consistency in my application tier, for example, via a pump. If I get that wrong, I may not even have eventual consistency. All eventual consistency says is, at some point, I will have a consistent view of the world. But you can still make mistakes until you have, in terms of how you break that schema apart. So the key thing to always understand when you're breaking that schema apart is, if I've got two services, service A and service B, you know, does that data need to be in sync? I think one of the examples I gave when I talked in the book actually is, I've got a record in my finance system that says we sold 58 items of SKU 123, and in my catalog service, I've got SKU 123, but I deleted that row. So now I've got an inconsistent view of the world, right? That happens. That you have the potential for that to happen when you break these things apart. Now, a model where a change in one system can emit an event that other systems can listen to, can allow you to implement an eventually consistent model. So, for example, I go to my finance system now. It says I've got SKU 1, 2, 3, 4, and we sold 100 items. And when I'm looking at it, I don't realize we've removed that record. We removed that record 5 minutes ago, and I haven't been told. Then an event arrives. My finance system says, "Oh, that's now been removed." And you can update the finance system and say, "We sold 100 items of SKU 1, 2, 3, 4, and that's an item that we no longer stock. It's now deleted." Now, I could use events. I fire an event. I could subscribe to that event to know that that change has existed. Things like event data pumps are often, I talk at a slightly lower level. So those things can be, the data pumps in general I talk about are ways in which you get information into databases. So if I want things like reporting databases, then those almost happen at a bit of a lower level. So those are, I wouldn't necessarily, for example, in my finance system, have a whole copy of my catalog. I might just subscribe to events. If I needed a local copy, then I might use an event data pump that's putting stuff straight into, say, a separate database that I use for reporting storage. So the answer is maybe, but just remember, just by splitting services and splitting schemas, you don't actually get eventual consistency for free. You often have to implement that yourself at the application tier.
Right.
And okay, we have our first question coming from RZ. This is coming from Kuba Z Kuba. And his question is, all these nice patterns like circuit breaker, bulkheads are nice, but come with some extra complexity. Assuming these are only used for synchronous communication, won't be easily to always strive for a synchronous communication between services?
Not necessarily, and in fact, both of those patterns, I think they're very, well, circuit breaker especially is very important with synchronous communication because it stops you from failing slowly. But those patterns work equally well for asynchronous communication. You know, for example, even if I'm doing, say, some sort of old school kind of message broker based asynchronous communication, if I know that message broker is down, or I know that the service subscribing to that message broker is down, I might still, on the client side, choose to trigger a circuit breaker saying, look, we know the thing downstream isn't working. Because remember, part of the circuit breaker isn't just about failing fast, it's also allowing us to programmatically fail. So if I have a circuit breaker about a known downstream outage, I can change the behavior of my application, let the user know, those sorts of things. So even synchronous or asynchronous, it still makes sense. Likewise, when you're sort of using low latency asynchronous communication, where you're not using, say, any middleware, using something like akka, for example, all of those patterns still make sense. So always striving for asynchronous communication, I think these are orthogonal concerns. Bulkheading, absolutely, I would still be using with synchronous or asynchronous communication. You know, all bulkheads say is if one part of my system fails, another part can keep running. And again, that for me is still a pattern I would be using, a reliability pattern that I'd still be using with synchronous or asynchronous communication. There are some types of technology used in asynchronous communication that can give us some resiliency for free. The message broker is one example I have. So if you had, say, a persistent message bus, I could put a message on it, and that message broker is going to handle that message doesn't get lost until it's actually been delivered. Now, all that I've done is I've pushed some of my resiliency concerns into that middleware, but my application doesn't actually know if that message has been picked up. It doesn't know if the downstream thing is even there. And so often people will still put higher order things on top of those, like the circuit breaker, in order to properly change the behavior of the application and handle those things. So it's a little bit of an interesting, it's sort of a misunderstanding, I suppose. I may not have explained myself clearly in the book. So, and my general advice actually is not to always go asynchronous, because I think most developers that I speak to, a lot of them are going from a monolithic process to a distributed system. And so a lot of our thinking, and I was like this for years, I was a single process developer effectively. And so I'm used to method calls, I'm used to how method calls behave. When you're moving into a distributed system, whether or not you deal with synchronous or asynchronous communication, you have a whole host of issues you've now got to bring in. You know, you've got to think about consistency and transaction integrity. You've got to think about different types of failure modes. You've got to think about how you do orchestrating of deployments. To then also say, by the way, all of your calls are now asynchronous is another level of, my head hurts. Which is why I always suggest start off with a simplistic form of synchronous communication at the beginning, because it's easier for you to understand how it behaves in terms of the failure modes that are obvious. And then go to asynchronous comms afterwards. Once you need, and you will do sort of a way. Now, if you're already quite familiar and happy with working with asynchronous communication protocols, you might go there earlier. But a lot of people I speak to, they haven't used message brokers before, for example. So that's my general advice is actually stick to asynchronous. Also, because at asynchronous HTTP, there are loads of great libraries out there to work out of the box as well. You're not as on your own as much. I hope that makes sense.
Yep, definitely. So we also have another question coming. Now it's coming from the YouTube live chat. So this is from fcracker79. It will be nice to see how splitting monolith into microservices deal with the domain module and the transactional scope.
Yeah, so transactional integrity is a real problem when you split monolithic systems. We often overuse the term transaction. So sometimes we talk about a business transaction. I'm sort of separated it out. So sometimes we use it to mean like a long-lived business process. But here I'm using transaction in the technical sense of the word, which is a set of changes that we all want to happen together or not at all. So this is the sort of classic view of what a transaction is. The challenge with you maintaining that form of transaction integrity across process boundaries is that all of the underlying principles rely on locks and some form of compensating transaction happening in the back end. So if I'm asking 3 people to do something and I need all of those 3 things to happen or none of those 3 things to happen, a classic way I might do that is say ask A to do something, then ask B to do something, and then ask C to do something, but sort of say to A and B, I want you to do this thing, but I also want the ability to tell you not to do it in case C fails, then I can go back to A and B and say, please, can you undo what you did? And that's sort of a classic 2-phase commit. Now, all of that requires coordination. And to coordinate, that means I have to effectively have distributed locks into those other systems. So I'm effectively trying to stop the state of the world across multiple processes. Now, there's a lot of really interesting research being done about making that highly effective. The most recent research around this, I was speaking to a database researcher, and the Spanner paper is worth looking at. All of the solutions that do that efficiently across multiple nodes and do that like Ignite the kind of efficient we're used to, rely on being in the same data center and things like that. So traditionally, when we're using distributed locks, we see distributed locking as a way of coordinating for things like transaction management. They are a source of latency. So they're not only, because I'm blocking the world, I'm locking, and that slows systems down. Inherently, it slows systems down. I'd imagine most people on this call, when they do a read from a database, even just within, say, a simple application database, when they do a read from a database, I bet you they don't do transactional reads. They probably do non-transactional reads. The reason they do that is because transactional reads are really slow. So we turn that off. So we know that locking is slow. The other issue is not just the slowness that is inherent with that locking that goes on. It's also the issue of rolling back state. If I go to A and say, can you do this thing? And B, can you do this thing? And C, can you do this thing? And C goes, no, I can't. I go, okay, right. So I go to A and say, A, can you undo that thing you were doing? And A goes, yeah, I can. And I go to B and say, B, could you unroll that thing you just did? And B's not there right now because it's offline for maintenance. And now I'm in a situation where as a coordinating body, I've got to maintain the fact that B needs to undo something and I can't even speak to B right now. And so I'm sort of stuck in a world that's in an inconsistent state. And those models are really difficult. And that's why in general, when I say splitting databases apart, splitting services apart, do everything you can to avoid situations where you have things that have to be completely transactionally consistent. If you do have those sort of concepts, say you've got 2 or 3 concepts that have to change together, actually maybe leave them in the same process for as long as you possibly can and work on something else. Because this opens up a whole world of difficulty.
Have you ever come across those difficulties before?
Yeah, and to be honest with you, a couple of places where this has happened, they've often been sort of low volume systems. And what we did was we relied on the fact that actually 90% of the time it kind of worked, and that 10% of the time things would get really screwed and you'd have to have manual backdoors. So I think I may have mentioned the last call doing some broadband provisioning type stuff. And the system there was a few different processes and things could get out of sync every now and then. But we fixed that by effectively having a customer service portal where you could go in and unpick things. But even then, that system wasn't using complete transaction integrity. It was relying on the idea that eventually, back to the point earlier, the system would come into being into a known state. The other things that I have done when I've had a few concepts that need to be transaction integral is effectively offloaded that to a database. So I actually had a very small use of some shared transactionally integral data store that 2 or 3 services might use purely for the use of coordinating a change in state. If you want to know more about the challenges of managing consistent distributed state, just type those terms in to Google and see all the research papers out there. And there's a lot of really interesting research out there. So a lot of the advice I give is general case. These problems may get solved in the future with new algorithms, new hardware. But for most people right now, if you want to manage consistent shared state across multiple nodes, this is one of the legitimately very, very hard problems in distributed computing. And actually something that isn't easily solvable without introducing challenges around severe impacts to latency, for example.
I see. Okay, Ivan, can you move forward with your next question, please?
Yeah, thank you. A lot about, you're right, actually, a lot of others. So let's start with in the deployment chapter. You mentioned that in most of the projects that you've seen, they have retrofitted somehow their continuous integration tool to do the continuous delivery work. But you would recommend that projects and people, developers, should use a special tool for continuous delivery. Can you give us an example of such a special tool that does the continuous delivery stages and steps?
Yeah, one of the core ideas behind continuous delivery is the ability to model all the steps that your software goes through before getting into production. So the core idea is that every check-in is treated as a release candidate. So I check it in, I create like an artifact that might represent my service. I move that thing through a series of steps and I tick them off. And I say, yes, that's good enough to pass. Let's go on to the next step. That's good enough to pass. So this core idea is a pipeline, is what we talk about as a pipeline. So if you read the continuous delivery book, you'll read more about it. I mentioned it in the deployment chapter as well. The issue is a lot of the original CI tools we had were really based on the idea of I might have multiple steps, but it's not really a pipeline. They're not being run by separate agents. So there are some tools that have really built this idea of pipelines in from the beginning. GoCD is a tool that I've been peripherally involved with. It's an open source tool for my old employer. So lots of people use that. That has this core idea baked in of these pipelines that you can create. And it was designed for this kind of work. Increasingly, a number of people have been very positive towards Concourse, which has some really nice concepts as well, in terms of, again, this pipeline idea. Some of the challenges around Concourse I've heard is quite opinionated, so you often have to adapt your build more to fit there. So I have a look at both of those tools are open source. I think Team City stuff isn't too bad either, but it has been a couple of years since I've used that. I've had less success with Hudson and Bamboo in this space. When I last used them, they didn't really have this sort of nice workflow idea. You could like add plugins, but it was a kind of a shoehorned in idea. So have a look at GoCD. And if you've got the ability to maybe change your build process a bit more, have a look at Concourse CI, which comes from, I think it's a spin out from the Cloud Foundry team at Pivotal. So that's also worth looking at.
Okay, great. Thanks.
Awesome. Yeah, Ivan, please proceed.
Okay, let's go to testing for a while. You talked there about the consumer-driven contract and that it can be a solution for some issues with integration testing, with end-to-end testing. Can you please explain what consumer-driven contract is? And when would you use consumer-driven contract tests instead of end-to-end tests?
Sure. So, you know, the problem we're trying to solve here is I've got a service A that speaks to a service B. And when I change, and so service A expects B to behave in a certain way. We may have an explicit understanding or an implicit understanding, but like when we do this, we expect you to do this, B. You should behave like this. And so when we're changing B, we have this problem. I make a change in code, I deploy B. How do I know whether or not I've broken A? And that's the key problem, because what we want to remember from last week, I think I talked about, is the idea of independent deployability. So I should be able to make a change to B and deploy that by itself into production without having to change A. But I need to make sure I haven't broken A. So I make that change. So how do I know? How can I test it? So we can do an end-to-end test where I can deploy A and B together, run some tests against it. But as many of you who have done maybe big end-to-end testing know, that could be problematic. You know, you have issues around ownership and time. The idea behind consumer-driven contracts is effectively we take that understanding. So A has expectations of how B should behave. What we do is we take that knowledge and effectively represent it as a series of tests. And there's different tools out there to do this. So ideally, the team who wrote A, they would say, okay, we're actually going to code up how you should behave. So write some tests. So when I do this, I expect you to behave in that way. The team that look after B, which could be the same team, they take those tests and they run them as part of their build. So whenever I run my build, I'm running the test for all of my consumers. And so maybe I've got consumer A, D, Z, Y, K. I might have 25 different consumers. I can have tests for all of them. And so when I make a change to B, I run all my consumer tests. If one of them breaks, I know, I'm potentially going to break somebody, and that could be problematic, and maybe I should talk to them or understand what I've done. And that's the core idea behind consumer-driven contracts, taking that implicit expectation of a downstream service, making that expectation explicit, and having the downstream service run those expectations as part of their build. They're the best way, most mature tool targeted at this use case out there is a tool called PACT, so P-A-C-T. There are ports for loads of different languages out there. The idea hasn't gained as much traction as I'd hoped, but it's getting bigger every year. So have a look at PACT and how that works. And it might be quite a nice way of giving you some of that safety without the need for sort of bigger end-to-end tests.
Okay, so the basic idea is that the tests are written not by the component that that is under test, but actually by its consumers.
Exactly. So
Yeah,
the key idea here is sort of, yeah, it's a mindset thing, right? When we write a service, we think we know how people are going to use it. And so when we write tests, we think we're sort of trying to pretend that we're the consumers, but we're not the consumers. And so sometimes we'll make mistakes. So the core idea here really is about actually us getting a real definition from our consumers about what they expect of us. If you're creating a new service, you probably have a conversation about this around a whiteboard. You might chat about the API. At that point, that's a great point to actually codify that and write it down as a test and say, well, when that passes, your service can be shipped, you know? So it can actually, if you build it into the service creation process, this can be quite efficient. It can be a bit more problematic in environments where you're retrofitting them in, especially if you don't know who your consumers are. Maybe they're not around anymore. That gets a bit more difficult. I go into a bit more detail in that chapter about other coping patterns, but that's the core idea is like, let's get tests written ideally by our consumers, but let's run them ourselves every time we make a change to really make sure we're validating that we're not going to break any one of our consumers.
Okay.
I mean, that's kind of like similar as writing like a TCK for whatever code you're writing, right?
Yes, yeah. The kind of difference here is that when you're say doing TDD development, for example, or you're writing acceptance tests before you write the feature or whatever else, you know, you are often the person doing both sides. The ideal thing with consumer-driven contract is the person who is going to be using your service is the one driving that a bit, and that kind of feels a bit weird to start off with. But when you come down to it, your service exists to be called by somebody else. Your API is a user interface to another party. And so really this is also about encouraging communication between people writing a service and the user of that service. And a lot of the time, those might be the same people, but a lot of the time they're not. So it's really about trying to think outside in as well, rather than inside out.
Yeah, so to add a little bit of my experience in that area as well, I've done that model in some of the projects I was working on as well. One of the things that we used that model was especially to make sure that we were not breaking any contracts between the APIs and whatever consumers were using those APIs. So, and keeping the code separate will definitely ensure that, because it's really easy to just, when you're changing code around, you just rename some stuff, and then you might miss that you renamed something on the API, and then the consumers are going to break. With that particular approach, that pretty much solves that, and at least, I mean, it's not one of the big points in my opinion, but at least help us on that department to make sure that everything that we developed didn't break when we develop it to the consumers.
That's a really important point. I mean, that's one of the that's one of the things that concerns people a lot when you talk about releasing services independently is this idea of a breaking change. And having a safety net to catch you before you make a breaking change is very useful. There's also something that becomes interesting, though. I mean, you might decide you do need to make a breaking change. You actually do need to change an API for maybe just maintenance reasons, internal performance reasons, whatever that might be. And if you have consumer-driven contracts in place, it can also help you understand, okay, I've got 25 different consumers. If I did make this breaking change, it looks like I'm only going to impact 2 services. So let's go have a chat to them about how we can make this work. So it actually even gives you a way to work out how to make breaking changes and who they're going to impact. So it can be useful for sort of both mechanisms.
Yeah, definitely. Let's see if we have something over here. Yeah, Ivan, just go on.
Okay. So we covered splitting the monolith, deployment, testing. I still have some other questions, but let's go to monitoring too. So you suggest that besides measuring things like CPU or memory or response time, we should also measure the usage of certain features. And sorry, how would you implement that metrics in a Java web application, for example? How exactly? Would you use JMX or?
Yeah, well, actually, this is the problem. So almost by, I think I've used this analogy before, but if you think of how an ant's nest works, if you look at an individual ant, you might look at that ant and say, well, that's a healthy ant. But that ant plays one part of how the whole nest works. And so knowing that one ant is healthy doesn't tell you if the nest is healthy. And for the nest to be healthy, you need to step back and look at overall big things like, are there enough new ants being born? Is the food coming in? All those sorts of things. And likewise, if you think about the example I gave in the book, which is we're selling CDs, maybe there are 25 services involved in selling CDs. And I look at all of those services individually, and each of those individual services say they're healthy. Yes, I'm up. Yeah, I've my CPU's within known bounds. Everything looks good. You've got green lights across the board, and nobody's bought a CD. And people normally buy 20 CDs a minute, and no one's buying CDs. Unless you actually step back and sometimes look at the bigger picture stuff, you're not going to spot that your overarching functionality might be broken. And so you actually need that bigger picture stuff. Now, the issue is that you can't necessarily just say, I'm just going to expose a number from a service. That doesn't always cut it. So just exposing a JMX hook, that can be useful for exposing, say, custom metrics. But all too often, I think you need something else. A technique I like a lot is this idea of semantic monitoring. And what it says is, rather than looking for the things that might be wrong, so looking for errors in logs, looking for high CPU, instead what I'm going to say is these things must be right. People must be able to buy CDs. That's one of the things that must be right. So then you've got to ask, how do I know if people can buy CDs right now? And so you sort of say, okay, so my semantic model is that my semantic model of correctness is at any point in time, people need to be able to buy CDs. So I need to validate that. One great way to validate that is to do something, to use something called synthetic transactions or synthetic user monitoring. And what you do is you create some fake user behavior that is trying to carry out this thing that you think must be true and has known outcomes you're looking for. So in the CD ordering, I might have a fake user that every 10 minutes tries to buy a CD. And so every 10 minutes, that person, I effectively have a little bit of code that actually does all the things from the outside of the system as though a user would do it. And so I know that I would expect that CD to be dispatched, although in my backend systems, I'll say not actually dispatch CD to say some known fake users. And so you're trying to exercise as much of the system as possible with this synthetic sort of call and validate that it's still correct. And so I've done this before with a trading system. So we're pricing these trades, and we would fire a fake trade off every 10 minutes. And that trade would go into a thing called the junk book, which wouldn't get booked into backend systems. But I was running over, we had like 200 or 300 machines running with CPUs. I don't care if 2 of my machines or 3 of my machines are 100 CPU, as long as I can still book trades. The moment my trades can't get booked, then I'm looking at the lower level things like my CPU to say, is there a problem? When you are doing this sort of stuff, when you are creating these sort of semantic models of correctness and injecting these synthetic pieces of user behavior, 2 things are important. The first is you still need to have that lower level understanding, because when a problem occurs, what's gone wrong? So you still need that belt and braces stuff. You still need things like aggregated logging. You still need to be capturing things like your CPU and memory, for example, somewhere. They just might not be the key things you alert on. The other thing that's really, really important is if you are injecting these sort of fake pieces of user behavior into your system, is make sure they're not destructive. So in our example of the trading company, we knew those trades for those users never actually got put out into the market. I spoke to a team in Germany about 3 years back now who were using some techniques like this, and they accidentally ordered 200 washing machines for head office using a technique like this. And they only found out when a truck arrived at their head office with loads of washing machines in it, and there was another truck being packed up in the warehouse. So if you are going to do stuff like this, be very careful that the thing you're doing isn't destructive of the back end. And there's all kinds of tricks for doing this, having known users that are test users, having fake production, but having fake postcodes, those sorts of things. So yes, have the low level stuff, but think bigger. Think what must be true. Work out how you validate what must be true, and just have that running all the time. Effectively, this is a form of testing in production. That's something I like quite a lot.
Yes, so actually coming question here regarding what we're discussing from Andres Mihaly. Yeah, I guess that you already answered a little bit. So he was asking about how could you make sure that when you're doing the synthetic monitoring, that the fake events won't affect production data. I'm guessing that, for instance, using known test users is one of the things that you mentioned.
So yeah, you might have like a whitelist of users, the people with these usernames. Maybe there's things that we know their test accounts. We know we're never going to put them in our back-end fulfillment, fake postcodes, those sorts of things. You're right to be worried about it. But you build it into your system. You might have to change your system behavior to allow this to happen, but I can't stress how valuable it was. The first highly distributed system I created was just completely opaque to us how it was behaving until we put this stuff in, and then they became like invaluable. I mean, I've just spent a year working with Atomist, which has a highly distributed system in the back end, and actually us having these sort of fake events being fired for our system mimicking user behavior became like super important. And so we actually had tools in place in Slack where when one of those failed, we could take the ID for that failed transaction, for that failed sort of synthetic user. We could put it into Slack. You could get information back about how it's behaving. We never actually finished that bit, but I could do it on the command line. But all those sorts of stuff. So these ideas are really powerful and useful, and they're the sorts of things that I strongly urge you to put in early. In fact, I would say, typically in the systems that I built more recently, I won't have a pager alert if a CPU is at 100%. I don't care. I care if I can't order CDs. So those actual higher order sort of semantic models of correctness, they become the things that actually generate your alerts over time, because they're much more likely to tell you if things are going well. You can also, of course, monitor off real user monitoring. You can do things like say, we know here it is in Australia, it's almost 9 o'clock in the evening. We know at 9 o'clock in the evening, we normally would be taking $20,000 in revenue. And right now we're taking $10,000 in revenue. We should wake somebody up. This actually comes back to this thing that Eric Ries, it's a question sort of that he posited, I think it's in the Lean Startup, it might be something else, where he says, would you know if somebody replaced your buy button with an invisible 1 pixel by 1 pixel GIF, right? So everything's functioning on the back end, but no one can click the buy button, right? Would you know if that's happened? And so having things like, we should be taking money right now, why aren't we? When you get really advanced, you can actually hook these sorts of semantic monitors into your deployment process. So one of the things that Eric did at IMView was when they did a deployment, in a certain window after deployment, if any of their key business metrics dipped below an acceptable threshold, they would automatically roll the last version of the software back. So they'd just say, yeah, we're not even taking a chance. We're going to roll it back and then let a human being look at it. But that all comes back from this idea that you even know what a good system looks like. So having some understanding about what a healthy system looks like, a well-behaved system, and if possible, defining that in terms of business metrics, not CPU, it becomes a lot easier to create systems that are well monitored with good remediation processes around them.
Yeah, so basically what we're seeing here is the shift from the traditional monitoring approaches where you mostly monitor like disk space, CPU usage, memory, from actually measuring business needs regarding whatever application you're working on. So in this case, of your CD application, you're mostly interested in monitoring the revenue that's coming in, I don't know, hourly, daily, whatever. And if you note like kind of a different number that you're used to look at, then maybe you have a problem, and then we're going to investigate what's going on.
Yeah, the challenge, of course, is if you want to alert off business metrics and you only get your business metrics out every day, that's not going to be good enough, right? So part and parcel of this is also can I get those business metrics out in a more real-time fashion? And so, just like Explore, you can expose any information you want from the nodes. You might actually have to build in the ability to export business metrics to allow you to have this more active real-time monitoring. The really nice thing is, by doing that, you're also potentially giving real-time business-related metrics to your business stakeholders that never used to have that before. I've worked with so many online .coms where their business stakeholders had to wait until the analytics job ran in Cognos overnight to get a report out the next day about what happened. And I'm there sitting in the ops team with this amazing real-time dashboards of everything. So I think the more you can get this information out in a real-time fashion, the more your business can react and decide what to do differently, and that you as a developer or operations person can react and make sure the system's healthy.
Yeah, awesome. So another question coming here from IRC. When you do monitoring, do you recommend the service monitor their dependencies? How this should be done if there are multiple instances of a service? Should every instance monitor those dependencies? And how to aggregate the data from all the instances?
Yeah, do I suggest you can monitor your downstream dependencies? Yes, I do. Because, coming back to A talks to B, A might be up and says, yes, I'm here. B might be up and says, yes, I'm here, but A can't talk to B for some reason. Maybe a misconfiguration, maybe a challenge around networking, a data center partition or whatever that might be, that could cause that thing to happen. So yes, I always do advocate doing that. There are some tools out there that will do this. So Hystrix, for example, for Java, is a circuit breaker library. It gives you a dashboard out of the box that will allow you to see those sorts of things. You can also just send normal health metrics through to roll those things up into a dashboard. The reason I would do it at every single node is because you can get some really weird things happening. So let's imagine I'm running my service instances on some virtualized boxes. 5 of my nodes are on one rack. Another 5 of my nodes on a different rack. I see that all the A nodes on the first rack can talk to service B. But then I see all the nodes on the other rack can't talk to service B. It's exactly the same version of the service, but in different places. And I realized what's actually happening is there's a networking issue with that rack. Now, if I only looked at one instance of that node, I wouldn't see that problem. And so there's a bunch of different dashboarding tools out there that you roll it up. Take a look at what Hystrix does. I've jury rigged those things in the past. But again, for me, this isn't necessarily something I'm going to alert on. It's something I'm going to look at when I see a problem. So I might drill into it. So this might be a level down. So yeah, I mean, you could do things, for example, like roll back up the number of nodes that can see their downstream services. And when that number's below the number of service instances, you've got a problem. So there are different ways of rolling that. But take a look at what Hystrix does with that. It can be quite useful. But I absolutely would suggest doing it. The other reason it's not just for monitoring, it's also for helping you understand a service. If I can go to a service node and maybe go to a health check page, and on that health check page, see the downstream services and see their health, then as a developer, I get to know how that service is plugged into the rest of the world. So I like doing it for both reasons. So I'd absolutely would suggest it.
Mm-hmm. Definitely. So still on monitoring, have another question coming in. About correlation IDs. What kind of techniques do you use to generate the IDs and pass it to other servers transparently?
Most languages out there have some ability to generate a GUID, and that's just what I do. I mean, they end up being long, and you can define lengths of GUID, but it's GUID libraries in pretty much every. So GUID, when I say GUID, you can generate those in most languages out there, and they are, okay, they're not guaranteed to be unique, but the probability of them clashing is so remote as to not be something you worry about typically. And so the key thing is I'm either generating a call for the first time or I receive a call for the first time. If I don't see a GUID associated with that call, I will generate one locally and then pass it downstream. Now, pass it downstream is where all the detail is, right? If I'm a Java app, and I'm doing something like, say, synchronous HTTP calls, I can implement this with a servlet filter that does before and after stuff and just pass that ID in the header of all the requests that go downstream. And that will take you like 20 minutes to do. If you're using other kinds of protocol, though, you're going to have to decide probably in-house how that GUID gets passed downstream. So maybe I'm communicating by sending JSON payloads over a message broker, in which case I've got to take that GUID, put it in a known field in that message payload, and the thing that subscribes needs to know it unpicks that message payload, it sees that GUID that represents my correlation ID, and makes sure it logs it for any requests associated with that within that context and passes it downstream. Other things, the very first thing I do is I put GUID. The very first thing I do from a monitoring point of view is I do aggregated logging. I get all my logs in one place, and then I put correlation IDs in. So get your correlation IDs into your log line. So every single log line in your logs should have a correlation ID in it that allows you to see how traffic is flowing through your services. And if you see a log line that doesn't have a correlation ID, ask yourself why. What's going on there? Should it have one? And so, because getting it plumbed in can be painful. It's much easier if you start at the beginning, but you may have to come up with some in-house conventions as to where it is. But yeah, just any good old-fashioned GUID generation library is perfectly good enough for that sort of stuff.
And you also discussed some of the tools that you use to see all these logs on your book. Do you care to elaborate some of them?
Yeah, I mean, there's loads out there. If you want open source that you want to have a host on premise, then the Elk Stack is quite popular. Elasticsearch, Kibana, and Logstash. Daemon on your machine pumps it some essentially dashboard to aggregate that stuff. If you want something really simple that's off premise, Papertrail is just very simple. You've got Sumo Logic, which does some very nice logging stuff. If you've got money, Splunk is amazing at this stuff. It's just really good, but it's really expensive, like eye-wateringly expensive. But it does stuff that nothing else can do. It's kind of crazy. There's plenty. So the key thing is, the first thing you're going to want to say is, I want aggregated logging, and it should be the first thing you say. If we do anything else in that monitoring chapter, do aggregated logging. Then the question is, do I want something I'm managing myself, or do I give it to somebody else? Increasingly, people are saying, I'll let somebody else manage this for me. And you could throw a rock and find a brand new startup doing logs aggregation for you. But I've used Papertrail and Sumo Logic. They're good tools to take a look at. There are other tools out there, but there's like LogZ. I think logz.io will even run the Elk Stack for you off premise. So, you know, have a look at those tools. But do log aggregation. Do it early. You'll thank me later.
Of course. Ivan, do you have anything else you want to ask Sam?
Yeah, I still have questions, but not sure whether we have time, because it's already...
Yeah. I tell you what I could do. I can do one more question, because I have unfortunately got another call. I can do one more question, and then here's my promise. My promise is I'll do just one more question, and if anyone asks me questions on Twitter, I'm just at Sam Newman on Twitter. If you want to ask me questions about the last 4 chapters, these that we've been talking about, chapters 5 to 8, I'll answer them offline. So just hit me on Twitter at Sam Newman. But I'll answer one more question, and I need to go to a call.
Okay, sorry about that.
No, it's fine.
Okay, so it's about testing and performance. How would you recommend setting up the performance test landscape? Because on one hand, it should be as close to the productive one as possible. But on the other hand, this might be too expensive for larger web applications.
I mean, I would start with something which at least lets you run some automated load or soak tests against any environment you can to get a baseline. Just be in that place. Most people don't even get that far. Can I run a line of code and have it run against an environment and just get some load metrics out? Start there. Pick a tool, just start with something. Because you might say, look, I know this environment here is a bit different to production. It's got 1/10 of the nodes, and it hasn't got the most, the firewall is actually, it's not, the load balancer isn't an F5 like it is in production. It's actually a software load balancer, but it's not quite the same. But we know that when we get this mark on our fake production, that relates to performance, the same version of the application that looks like that, and we know that's okay. And then at least you can scale from that. You sort of get a sense of, as long as we know from the past, or if we get this number or this level of performance in our fake production, we know the production performance we're going to have is normally good enough. And so just start with something. Now, over time, you can make it more production-like. But the very first thing is, can I write something that is fully automated, that runs against some version of my application, and gives me some numbers out, and that lets me do things like scale up the amount of load I use. Can I hit it with just one user? Can I then hit it with 10, 100, 1,000? Do I have a tool that lets me do a soak test over a weekend that looks for memory leaks? And something that lets you get those results back in a way that people and human beings can look at. Once you've done those pieces, automated running of these things, sensible collection of data that can be interpreted, you can then work afterwards to make this thing more and more production-like. But just start with that basics and it will be beneficial.
Okay.
Okay, so we're going to wrap this up. Thank you so much, Sam, for joining us on the second session, and thank you for all your audience sending the questions in. We're really sorry for this rocky start. We had a problem with the Hangout, but we guess we were able to pull it through. Yeah. Don't miss our last and final session with Sam. It's going to be on 23 February. I'll schedule the event in the next couple of days, so you can sign up and join us for the final session with Building Microservices Sam. So thanks again for everyone, and
Thank
see you
so
next
much.
time.
No worries.
See you in 2 weeks.
Yeah, and don't forget on Twitter, @Sam Newman, ask me any questions you want, and I'll see you in a couple of weeks, guys.
Okay. Bye-bye.
Thank you. Bye-bye.
Thank you.